Problem 7. A truck is shipping jugs of drinking water and cases of paper towels. A jug of drinking water weighs 40 pounds and a case of paper towels weighs 16 pounds. The truck can carry 2,000 pounds of cargo altogether. Before we finish part A, which is to complete the table showing 3 ways the truck could be packed with jugs of water and cases of paper towels, we're actually going to move on to part B and look at the equation that would relate the number of jugs of water W and the number of cases of paper towels T the truck can carry. So first, we are going to underline the important pieces of information, which is the number of jugs of water is W and cases of paper towels is T. And we're going to go up to where the problem gave us how much a jug of drinking water weighs, which is 40 pounds. And we're going to relate that to our W. So for every 1 increase of jug of water, we're going to have an additional 40 pounds of weight. And we're going to add that with the cases of paper towels and how much that weighs. It told us at the beginning that a case of paper towels weighs 16 pounds. So we're going to write 16T. That means that for every additional case of paper towels, the weight is going to increase by 16 pounds. So we're going to set this equal to what the truck can carry altogether, which is 2,000 pounds. Now that we know our equation, we can go back to part A and finish our table. So if I were to write the equation out again, our 40W plus 16T equal 2,000, we can then plug in the W as 10 and solve for our T. Okay, so we already know that 40 times 10 is 400. So we're going to write that out. And in order to isolate our variable, we need to first subtract 400 on both sides. I'm going to show this step by step, and we're going to subtract 400 on both sides, which really leaves us with 16T on the left side and 1,600 on the right side. And next, we are going to divide both sides by 16 because the inverse operation of multiplication that we see between 16 and T is division. So now the 16s will cross out, and we're going to be left with T is equal to 100. For the second row, we are given the cases of paper towels T. So instead of plugging in a value for W, we are going to plug in a value for T instead. So you're going to write 40W plus 16 times that T value, which is given to us as 50, and we're going to still set it equal to 2,000. And with this information, we're going to now solve for W. So we're going to write out this step by step. We still have 40W. We're going to add that with 16 times 50, which is 800. And we're going to set it equal to 2,000. And in order to isolate our variable w this time, we need to subtract 800 on both sides first. And when we do that, the 800 is crossed out on the left side, and we're left with 40w. And on the right side, we are left with 1,200. Now we're going to do the inverse operation of multiplication, which is division. We are going to divide both sides by 40 so we can isolate our variable w. And when we do that, we end up crossing out the 40 on the left side, and we are left with w is equal to 30. And for our final row, we're going to plug in a w value of 50, similar to our first row, and we're going to add that with 16t because we don't know what t is equal to, so we're going to find out that value by isolating that variable. Now on the left side, we have 2,000 plus our 16t, and again we're setting it equal to 2,000. And in order to get rid of the 2,000 on the left side, we must subtract it from both sides. And so then we are left with the 16t equaling to 0. Now that's an interesting case because if you look, the way to isolate our variable is actually by dividing both sides by 16. So we know that 0 divided by anything is just 0. And 0 is our answer for the cases of paper towels. And this means that when our jugs of drinking water is 50, we have 0 cases of paper towels. Okay, next we are going to focus on the sketch of the graph of the solutions to our equation. And we are going to label our axes in intervals of 10, with the x-axis being the jugs of drinking water, W, and our y variable being the cases of paper towels, T. And we're just going to plot the points that we already have in part A. So when W is 10, we have T as 100. So we're going to plot 10 and 100, which is right over here. And I will label this coordinate point as 10, 100. And if you take a look here, second row says that when W is 30, T is 50. So I'm going to locate 30, 50, which is right over here. And lastly, we have 50 jugs of drinking water and 0 cases of paper towels. So I'm going to locate 50, 0. And lastly, we are going to connect all of the points. I will try my best to create that straight line. And I know that the linear function actually continues on our left side, because I know that there's some y-intercept. We just don't know what it is right now because we didn't plug in when x equals 0 for this equation. So what that means is that we didn't plug in w as 0 to find out what t would represent, but we know that it's going to be somewhere above 100. So I'll just draw an arrow to indicate that.